Hello, good evening everyone. Welcome to BYJU'S exam prep. So I would like to know whether the voice is clear or not. Yes. So the audio and the video quality is absolutely fine. So let's start the session with the topic that is the pulse code modulation. So this is going to be our last question series for the communication system. So if you need more question series on communication system, just do comment in the comment section because on the basis of your response only we can bring the different series, right? And according to what you need in your preparation, we can take a different session like a strategy session, question session, concept session. So whatever you are looking for in the YouTube in this particular channel from me, then you can just comment in the comment section, then I will definitely provide you according to the your demand, right? So quality B is saying the comment more. Yes, he is asking for the more session like this. So guys, we are actually bringing a session that is a monsoon series. So we are bringing a monsoon series, and this monsoon series I will bring more questions session irrespective rather than the concept session. Okay, so I will bring more question session, or you can say I will keep more question session rather than the concept session, right? So that demand, like neither quietly B is saying, so according to his demand, I am taking one acceptance, means I am taking that demand and into consideration, and I am bringing one question series in the monsoon series, right? So before starting the session, let me introduce myself. I am having more than 13-year experience. All right, and if you are not aware about me, so my name is Saket Verma, and I have done MTech from IIT Guwahati. And my area of expertise are electromagnetic theory, communication system, advanced communication system, signals and system. And this is the Telegram group where you can join for the PDF and the other question series, like on the daily basis. If you want to ask any question, if you want to correct me, then all these things you can do by the Telegram, right? And you will get the link of the question also. So just do share this session in the YouTube, okay, in the Telegram, so that the maximum students can take benefit of this. Yes. So now this is the monsoon series that I was talking about. From the next Monday, that is coming Monday, 10th of July, we are bringing this series, and you can get the scholarship test and this scholarship for the full course by the offered by the BYJU'S exam prep for the GATE examination, for the ESE examination, and you can avail up to the 90% discount or the off in the overall price of the GATE course, and that scholarship test will be held on the 9th of July 9 a.m. So don't forget 9 July 9 a.m. So this is the first question, guys. So that is the first question. So let's take a so I'm giving you some time to solve this question. Let us say I am giving you 1 minute to solve. Yes, so quietly be that you are asking for the 6 month strategy, and that session we have taken in the our app. So if you have not downloaded the app, just do subscribe this channel and also download our BYJU'S exam prep app, where we have already given the multiple strategic session, out of which this last 6 months strategy session is also there. 200 plans for gate that I have discussed. So in this question it is given that a uniform quantizer is used to quantize a random message. So this is a random message signal it is providing by the uniform quantizer, whose amplitude is uniformly distributed in the range of -a to a. And if the maximum allowed quantization error is 0.1% of the peak value of the message signal, then the minimum number of bit per sample required by the quantizer is. So you know that the maximum quantization error that is allowed. Okay, so the maximum quantization error that is allowed is plus delta by 2. So we are looking for the maximum allowed error is 0.1%. So this quantization error should be less than equal to 0.1% of the maximum value of the message signal, that is A. Now what is the step size? The step size is the highest value of the message signal divided by lowest value of the message signal divided by number of levels, and this is divided by 2 also there. So less than equal to 0.1%. So you can write it as 1 upon 1000. Okay, into 0.1% of AM. So 1 upon 1000 of AM. What is the maximum value of message signal? That we will write. Maximum value of message signal you can denote it by VH, because we are denoting the highest value of the message signal from here. So you can see that this message signal is having the amplitude between -a to a. The amplitude is uniformly distributed in the range of -a to a. So it is 2a, the maximum value and the minimum value, the difference, and this is 2L, and this is also a upon 1000. So this a and a will get cancelled, and then this 2 and 2 will get cancelled, and this L should be greater than equal to 1000. So L should be greater than equal to 1000, right? So what should be the minimum number of bit per sample to get the quantization level 1000? What should be the minimum quantization level to get the number of levels 1000? So if I put n equal to 10 suppose, then I will get the quantization level as 1024, which is greater than 1000. If I put n equal to 11, then I will get what? 2048. When I put n equal to 12, we will get 4096, like this. So all these are giving me the number of quantization level greater than 1000. So what is the minimum number of bit per sample? The minimum number of bit per sample is 10. So the correct answer should be n equal to 10. Now coming to the second question. Consider a telephone line having a bandwidth of 4 kilohertz. So the bandwidth of the channel is given as 4 kilohertz, because it is talking about the telephone line. It has to transmit the data at a rate of 6 kbps. So the data rate is 6 kbps, right? Using the raised cosine pulses. Using the raised cosine pulses, the rule of factor is. So when we talk about the rule of factor and the simple bandwidth is given and nothing else is given, that is the raised cosine pulse is given, then the bandwidth is given by RB by 2 for the PCM. So this is 4 kilohertz. So it is 4 kilohertz is equal to RB by 2 1 plus alpha, because it is talking about the raised cosine, so we have to write the RB by 2 1 plus alpha also. So RB is 6 kbps divided by 2 1 plus alpha. So this 10 to the power 3 and this kilo will get cancelled, and we will have 8 upon 6 minus 1. That is nothing but the value of alpha. So this is nothing but a 2 upon 6, right? So the value of alpha is 1 by 3. So how many of you have got this answer? Yes, alpha is equal to 1 by 3 is the correct answer, right? Next is, if you talk about this question, a pulse PT with the spectrum of PF is shown in figure satisfies the Nyquist criteria for the 0 ISI if the f1 plus f2 by 2 is equal to 1 megahertz and f2 is equal to 1.2 megahertz, then the roll-off factor is. So here you can see that if I want to have the 0 ISI, then it should follow the Nyquist criteria, and the pulse is given in this form. Actually the right side is already given, but it is inherently the left hand side is also present. So f1, f2 and f. So this is P of f. 0 minus f1 and minus f2. Okay, so this is the complete pulse, and for 0 ISI, for 0 ISI, the summation n is equal to minus infinite to infinite P of f minus n into RB, or RS also you can write if you are using more than two leveling of the coding, right? So now if you are having the P of f minus NRB, that is should be constant, and if it is coming constant, then you can say that it will have the 0 ISI. So how will you get this pulse as a constant? So for this you have to draw the signal in such a way, because P of f is already given. Now P of f minus NRB, P of f minus NRB. So it would be like this. It will start from here. Okay, and it will start from here. Like this. This is our for the different value of n. Okay, this is n equal to 0, this is n equal to 1, this is n equal to 2, this is n equal to minus 1 and n equal to minus 2 and so on. So this is nothing but the summation n equal to minus infinite to infinite P of f minus NRB is equal to constant. You will get constant when it will be overlapped like this. So this is the value of f1 and this is the value of f2. So in this question it is given that f1 plus f2 is equal to 2. So this is nothing but the value of RB. Okay, this is nothing but the RB. So you can see that this is nothing but the RB, which is equal to, up to this point this is f2, and this gap is f1. So this gap is also f1, right? This is f1, and this gap will also be f1 because of center point. The distance from the center point to the first slope change is the f1. So when we calculate it, we will get f1 plus f2 is equal to RB, and it is given that 2 from this given data, f1 plus f2 is equal to 2. So you can say that it is 2 Mbps which is given to us. So the bit rate we have calculated. Now we have to calculate the bandwidth, that is RB by 2 1 plus alpha, because we want to calculate the value of alpha. So what is the bandwidth? So bandwidth requirement of the signal will be to transmit the signal P of f. The bandwidth requirement, because this is our original signal which we want to transmit. So what is the bandwidth of P of f? So the bandwidth of the P of f is f2. So the bandwidth of the signal P of f is nothing but f2, and the value of f2 is given as 1.2 megahertz. So this is 1.2 megahertz, right? Now the bandwidth we have said that this is equal to RB by 2 1 plus alpha, and the bandwidth you have calculated as 1.2 into 10 raised to power 6. The RB you have calculated as 2 into 10 raised to power 6 divided by 2 and 1 plus alpha. So this 10 raised to power 6 will get cancelled, and 1.2 equal to 1 plus alpha. So alpha is equal to 0.2 will come. So alpha is equal to 0.2 will come. So that is the value of roll-off factor. Any doubt in this question? Then you can ask. Now next question, consider a stationary random process having an autocorrelation function given by Rx tau, where A is equal to 5, assuming the bandwidth of the random process as 5 kilohertz using uniformly sampled Nyquist rate. A random process is having the bandwidth of 5 kilohertz. The bandwidth requirement for the transmission if the non-return zero signaling is used with the minimum signal to quantization noise ratio is 40 dB. What is the bandwidth requirement? So first of all, you should know that the bandwidth requirement in case of non-return zero is RB. So we want to calculate the bit rate, and because the signal to quantization noise ratio is given, that is nothing but 10 raised to power 4, it is nothing but the signal power divided by noise power. Okay, now we can calculate this noise power by signal power divided by 10 to the power 4. So what is the signal power? Signal power we can get from the autocorrelation given for the signal. So we have the autocorrelation for the signal, which is a square by tau, a square by 2 e to the power minus tau cos omega naught tau. So the signal power we can calculate at the autocorrelation tau equal to 0, because for tau equal to 0 we get the power. So that is nothing but the 25 divided by 2 into 10 raised to power 4, because at tau equal to 0 you will get a square by 2 and a is 5, so 5 square, that is 25 divided by 2, e to the power 0 is 1 and cos 0 is also 1. So this is our noise power, which is delta square by 12. Because the bit rate is n into fm, right, n into fm, so the message signal is having the bandwidth 5 kilohertz, it is given. Now we want to calculate the number of bit. Okay, we want to calculate the number of bits. So you can see that this is nothing but a VH minus VL whole square divided by 12 into L square is equal to 25. It should be like it should be greater than or equal to signal to noise. So noise power should be greater than equal to. So this should be greater than equal to, and it should be greater than equal to. Okay, so this is 25 upon 2 into 10 raised to power 4. So because the maximum amplitude is 5, so 5 minus 5 is 10, minus or minus 5, that is 100 upon 12 into L square should be greater than equal to 25 upon 2 into 10 raised to power 4. So if we solve this, we will get 2 into 10 to the power 4 divided by 3 should be greater than equal to L. So the number of level is 20,000. Let me check this by calculation. This is 20,000 divided by 3. So we are getting 6,000. So number of level is 6,000. It should be less than equal to 6,000, 667 something. So how much bits are required? For 12 it is 4096. So 2 to the power 13, how much it is? 2 to the power 13 is 8192. So at least 13. So 13 bit will be required. So L should be less than equal to 6000. Correct? Signal to noise ratio is minimum 40 dB. It can be greater than that. So signal to noise ratio, which is this one, into the number of bit will be, just to check once again. So 5, highest value is 5 and the lowest value is minus 5. So this is 10. 10 square is 100 divided by 12 and 12 square. And tau equal to 0, that is 25 by 2, and this signal to noise ratio is 10 to the power 4. Correct. So up to this point it is looking right, and this is 2 into 10 to the power 4 divided by 3. So from here, if I say the number of levels should be minimum of how much? 14. The number of bit required will be 14, because 2 to the power 14 is 1618. Okay. 13 is also good. 13 is also looking good. Okay, now tell me. SQ and R, this signal to quantization noise ratio should be greater than or equal to 40 dB. So yes, that is what I was doing wrong. This should be greater than equal to actually. Okay, signal to quantization noise ratio is minimum of 40 dB. That means signal to quantization noise ratio should be greater than 40 dB. So according to the formula, signal to noise quantization noise ratio should be greater than 40 dB. That means signal power divided by noise power should be greater than 40 dB. So this should be greater than 40 dB. So greater than equal to, because it is also minimum. So according to this, okay, according to this, the number of levels should be greater than 6667. So 6667 we are getting, and that is L square, guys. Okay, that is the L square that we are calculating. So that is why I was doing some mistake. I was feeling that no answer was not getting now. So 2 into root over 0.66 into 10 to the power 4. So it is around 81. Number of level is 81 we are getting. So the number of levels should be greater than equal to 81 something. So that means it is minimum of n equal to 5, 32, 6, 64 and 7 levels are required. Minimum of 7 bits are required to represent the 81 levels. So 7 bits are required, and what is the bandwidth? Bandwidth is n into fm. So the bandwidth will be n, that means 7, and fm is 5 kilohertz, which is given to us. This is 5. So this is 35 kilohertz. Answer is 35. Okay. Are you getting the point? That mistake that we are doing. Signal to quantization noise ratio should be greater than 40 dB. It is not less than 40 dB. It is greater than, because it is the minimum value. Okay. Right. So next question. A signal is sampled and ideally sampled with the sampling frequency fs. And now if the sampling signal is passed through ideal low pass filter, then what are the frequency component appear? So it is the case of multi-tone. So f1 is equal to how much it is? 200 hertz. And f2 is equal to 320 hertz. Right? And the sampling frequency is also given. So whenever we sample the signal which is multi-tone, the frequency component which appears at the output is f1 and f2, and then fs plus minus f1, which is 500 plus minus 200, that is equal to 300 and 700. Then 2fs plus minus f1, so it is 1000 plus minus 200, that is 1200 and 800 and so on, because the 400 is the cutoff frequency of the filter, so we are not going beyond this. Similarly, we will have the fs plus minus f2. So fs is 500, f2 is 320, so we will get 180 hertz and 820 hertz. So again it is not required. 2fs plus minus f2, so 1000 plus minus 320, it is 680 hertz and 1320 and so on. But we don't need to calculate. Now if I see the cutoff frequency, this is less than 400 will be passed. So what is the frequency which are less than 400? So this 200 is less than, 320 is less than, and 300 is also less, 180 is also less. So 180 is there, 180 is here also, 200, 200 here, 200 here, 300, 300 here, and 300 and 320. Yes. So answer is option C. Option C will be the right answer, because these are the frequency component which will pass through the low pass filter, because the low pass filter is having the cutoff frequency 400. That means it will allow all the frequency which is less than 200. Okay. Now, data at a rate of 12,000 bits per second is used to transmit using M-array PM scheme. The minimum transmission bandwidth with the 0 ISI is B1 and the transmission bandwidth required when the Nyquist criteria pulse is followed, that is alpha is equal to 0.2. Then what is the difference between the bandwidth? So the bandwidth in case of first, when we are talking about the 0 ISI, but we are not using the roll-off factor, that is simply RB by 2, right? And what is the bandwidth for the M level scheme? So RB by 2 log base to M, okay? RB by 2 log base to M. And when you talk about in the second case, this is nothing but the RB by 2 log base to M and 1 plus alpha. So now you want to calculate the difference. So let's say B2 minus B1 or whatever it is, because we are taking the mod. So here RB by 2 log base 2m is common in both, and this is 1 plus alpha minus 1. So this 1 and 1 will get cancelled and we will get RB by 2 log base 2m and alpha. So bit rate is given, which is 12,000. Alpha is 0.2 divided by 2 into log base 2. M array scheme is given, whereas 16 is given. So that is 12,000 into 0.2, that is 2 into 8. So let's solve this. So this 2 and 2 will get cancelled, this 0 and 0 will get cancelled. You will get 150. Okay, 150. So the difference is 150. So that would be our answer for this question. 150. We just want to calculate the difference between the bandwidth when we use this 0 ISI scheme without roll off and with roll off. So guys, thank you for watching this session, and don't forget to subscribe the channel, because I am going to bring more question series for the communication and EMFT and signals and system in this particular channel. As your exam comes near, I will be bringing more questions and question series. So, and tomorrow I am having session where I am going to discuss you about how to prepare the communication system, because in the last 3 sessions, if you have understood all the topics, then well and good, and if you are not understood these topics, that you are not able to solve questions from these topics which I discussed in the last 3 days, then you can come and join the tomorrow session, because where I am going to discuss what are the different topics which are important for you, and how can you approach to those particular topics, and how can you prepare the subject from the scratch. Just don't forget to subscribe the channel and join our Telegram group for more detail about the upcoming sessions and links. Thank you.